Oh, drat these computers. They're so naughty and so complex. I could pinch them.
What's up, everyone, and welcome. In this episode, we're going to talk about malicious PDFs. It's hard to imagine business proposals without them. The PDF format is used in almost all companies to share business deals, company brochures, and even invitations. PDF is widely used because it's flexible. It can contain text, image, codes all at the same time. Many people don't know, but it's even possible to play games in PDF files like tic-tac-toe, for example. The problem is that this flexibility has a dark side, which is exploited by hackers. So, the simple act of opening a PDF file can endanger important information from your organization and even open a backdoor so criminals can access your devices. Being the most common email attachment, PDF is commonly targeted to breach computer networks. Advanced forms of PDF malware are not easily detectable, even by secure email gateways. Malicious PDFs is what we're going to take a look at today, along with steps to take to detect and avoid being affected by these attacks. Let me take a minute to give you some powerful reasons why you should share this video. Now, if you have seen this before, feel free to skip to the next section or just enjoy it again. If you haven't seen it yet, I want to show you how you can be a superstar in your team and your company just by sharing this video. First off, I really appreciate you watching this episode, liking it, and of course, subscribing to my channel. But I ask you to share it through any and all channels you have access to, whether Facebook, Twitter, LinkedIn, YouTube, Pinterest. You can link to it from your websites or even send it in an email to your colleagues, friends, and family. If we can spread this information to enough people, we all together can work to make the internet more secure. So, share it with developers in your team or developers that you know so they can integrate the security measures I will outline in this episode directly into their workflow. Share it with quality testers in your team or ones you know so they can benefit from this information and improve things like writing their acceptance criteria and test cases. Share it with project managers and product owners so they can make sure projects have the right security principles in mind and can talk intelligently to stakeholders about the importance of these measures. Share it with CEOs, VPs, and managers to show them that you're on top of these topics, taking them seriously, making you look like a superstar in their eyes. And finally, share it with your mom, dad, grandma, or friends, or anyone you can think of. Keeping them safe and helping them have a safer experience on the internet will definitely save you time and headache. Now, if you haven't already, right now is the perfect time to pause this video and share it before we really get deep into the content. Thanks again for your support. Here's a look at our agenda. Right now it's a blank screen, but guess what? We're going to start off with a definition. What are malicious PDFs? In order to build a good defense, we must intimately know our enemy. We're going to follow that up by the anatomy of the attack. How does it work? If we know the pieces and how they work, we can evaluate where we're vulnerable. We're going to finish up with what can I do? Steps to improve. We're going to look at how we can implement measures to either fix for good and or continuously scan systems to ensure it does not happen or happen again. So, what is a malicious PDF? PDFs have the ability to deliver rich content, static and dynamic. Combined, these elements can deliver visually appealing. Looks delicious, but I'm a cookie guy, so I'm going to switch to this screen. As well as interactive and portable documents. While we have all benefited from this feature-rich information sharing venue, there exists a darker side. The dynamic PDF capabilities mentioned above can and have been used to house malicious content. In previous years, cyber criminals embedded malicious script to install malware and steal user credentials. So normally, the PDF malware's malicious behavior is in a script that is embedded in the PDFs. The scripts that are responsible for the malicious behavior can be written in script language that PDF supports, JavaScript being the most popular for this purpose. In most cases, the embedded scripts are responsible for what's called dropper functionality, or else there is a need to install an operating system-based malware on the victim's machine. In many kinds of malicious PDF attacks, the PDF reader itself contains a vulnerability or a flaw that allows a file to execute malicious code. There are many PDF readers. There's Adobe Acrobat, there's Foxit, there's Goodreader, there's Phalanx, Slim, Stanza, Sumatra, and on and on and on and on. on. But we have to remember that PDF readers aren't just these kinds of applications. Most web browsers contain a built-in PDF reader engine that can also be targeted. So Chrome, Firefox, Safari, Edge can all be used to read PDFs and in turn introduce vulnerabilities that can be exploited via the PDF. In other cases, attackers might leverage what are called acroforms. These are form elements that layer above the content. It uses a kind of two-step approach where you define the content layout and then you apply field elements on top of them. Or they might use what are called XFA forms, which use the Adobe lifecycle. And you have to think about sort of how the data should be transformed. Using a design process, again, you define your entire data schema and then you build a UI around it. If you want to look at kind of how they compare, acroforms are portable. They work on all platforms. It's always presented in a consistent way. They're page-oriented and they cover both documents and form elements, while XFA, the data in the schema are XML-based. It focuses only on forms. The layout is dynamically driven by data, and the PDF itself is just a wrapper around this XFA. Both of these are scripting technologies used in PDF creation that were intended to add useful interactive features to a standard PDF document. To the average person, a malicious PDF looks like another innocent document, and they have no idea that it is executing code. According to Adobe, one of the easiest and most powerful ways to customize PDF files is by using JavaScript, and therein lies one of the key exploitation methods used to infect or to drive you to some kind of malicious action or activity. So how does this all work? How do criminals use these PDFs? There are different ways to manipulate PDFs. In general, the most common techniques used by criminals involve these four. The first one, JavaScript, which I've already mentioned. Many PDFs already contain JavaScript code, and you don't even know it because you don't see it. There's nothing really there until you maybe perform a specific action where the JavaScript is invoked. There's no symbol or sign or like, secure lock on it or anything like that. There's nothing that indicates that this particular PDF has JavaScript embedded in it. So without you knowing, it could end up running malicious files. Another method is URLs. In order to prevent antivirus and any other engines from detecting the threats in the email content or the PDF itself, the criminals embed malicious URLs or links into PDFs. Now, there are different methods to have it. You could either click on if they put a link there and you click on it, it brings you to a malicious site, or if they use what are called actions and triggers, so that as soon as you open the document, it triggers an automatic action to open a URL in a browser. The third would be embedded files. Some PDF readers use a blacklist to block file types based on extension, so a RAR file, zip file, exe, or VBS would be blocked, but there are many types of other files that can be embedded and exploited by criminals: Word documents, QuickTime files, Flash media files. The final one is encrypted PDFs. So it's not the first PDF that's encrypted. It's actually possible to embed an encrypted and malicious PDF file inside another PDF. The technique is mainly used to deceive detection engines. So PDF file viruses are mainly spread through email. You could call it phishing email, but it's always like an attachment in an email, or not always, but mostly, or by drive-by downloads in malicious websites. The bad, ugly, and notorious guys dupe you into opening this and clicking on some attachments, and enable macros and enable editing. In such cases, the PDF file has an attached document inside, and this is kind of like the embedded encrypted PDF, but it's an embedded, say, Word document. And the document opens and requests you to enable editing through a social engineering attack. This runs a Visual Basic for Applications macro, which downloads and runs a ransomware. So once the ransomware is run, you'll see a message asking you to pay a huge ransom to access your files. Something like this. For all of you that have seen any of my other episodes on ransomware, for example, Epsilon or Black Cocaine or Ragnar Locker, or any of the ones that I've done on my channel, this kind of screen is familiar to you. There are also instances where a malicious website could use JavaScript or applet to check if a PDF viewer plugin exists in your browser. If it does, this will enable the malicious PDF file to load. So now we're going to get a little bit technical. I'm going to dive into a PDF document and structure. The general structure of a PDF file is composed of the following code components. Let me turn on my pointer. It contains Boolean values representing true or false, which I actually don't see any Boolean values in this particular example. Numbers, which would be the numbers everywhere, but these would be numbers of objects, object number 1, object number 2. Strings, names, arrays, ordered collections of objects, dictionaries, collections of objects indexed by names. You would have streams, usually containing large amounts of data, and this particular one only has a little bit of data. And then you would have the null object. So you have various different components of a PDF wherein things happen. So you have objects that can contain code, you have streams that can contain data, so on and so forth. The following actions are defined in the PDF standard and are ultimately candidates for manipulation. You have the go-to, which is not necessarily a direct manipulation, but the go-to a destination within the document that they can then trigger some other action, which will then be malicious. You have go-to R, which is go-to remote, which means go to a remote destination. You have go to E, which is go to an embedded destination. Submission of a form, submit form, send form data to a URL. The URI call, which is resolve a uniform resource identifier, or essentially open up a website. Importing data, importing into the field values, and then if you have malicious field form validation, that could be an exploit. You have the thread, begin reading an article thread. You have launch, for launching an application. As I mentioned, files that could be embedded and called, they might block exe and VBS files, but you could open a Microsoft document or a QuickTime file, and in turn, you'd be opening up an application to open that file. So you'd be opening up QuickTime to open up a QuickTime file, or Microsoft Word to then, in turn, open up this malicious Microsoft Word file, so on and so forth. And then you have just plain JavaScript to execute the code. We're going to look at really 3 quick examples here. Although you could say it's 4, but it's really 3. So the first one is the go-to-R. This action is useful for connecting different PDF documents and jumping or navigating between them. So if you have PDF 1 and you have PDF 2, you can embed a link or an action that says somebody gets to this page or clicks on this particular link, go to page 2 of PDF 2. And then you can link back to PDF 1. The code for a complete attack that combines automated execution when a document is opened, or the open action, with a go-to-R action that points to a malicious destination, which is a non-standard path, looks like this. So here you have your open action and you have your go-to-R action. And here is your, let's say, malicious URL or malicious file. The key S here, this S here defines the type of action, which, as we said, is go-to-R. The F specifies that the following path is a file specification and the destination path. So this would be an SMB path. The D defines that it's the page in the destination. So here would be 0, which would be page 1. And then you have go-to-E, which I have up here. It's essentially the same. The action is quite similar to the previous go-to-R action. Its structure is identical, and it is also possible to manipulate the path of the embedded file specification. So it's basically the same thing. One is go to a remote destination, and the one is go to a embedded destination in the same file, but they can both be exploited the same way. The next we're going to look at is URI. URI, in the URI action, involves or resolves hyperlinks to web resources, so it opens up a web page. The execution of this action opens the web resource that is defined in the action in a web browser. That's why you have HTTP here, because it indicates a web link. In combination with automated triggers, it is possible to automatically open a web resource when a document is open. Now, if you remember back to the 4 different standard ways of using it with URL, I said it could be, when you open the file, it could automatically open it, or they could try to dupe you into clicking on a link. This would be the automatic method. As soon as you open the file, this would be called, and then this here says that it's an automatic open. So a prototype snippet to achieve a malicious implementation looks like this. This code shows the combination of URIs with an additional action AA trigger. But the open action trigger would also work in this case. The O here defines that the action is automatically executed when the page is opened. It's important that if you have like more pages, if this particular action is on, let's say, page 5, and you want it to open when the document is open, then you need to put this AA all the way at the top of the first document. So this triggers and says all automatic actions, regardless of the page, should be triggered. Now, the fact that this opens up a URL doesn't necessarily say that, okay, it's infecting your machine, but this URL could lead to a malicious website, and if that malicious website combines cross-site scripting, like let's say it's a fake JP Morgan Chase Bank URL or eBay URL, and uses cross-site scripting, it can ultimately lead to a larger surface attack. Last one we're going to look at here is the submit form. This action is kind of a hybrid between the go-to-R and sort of URL, because it was originally designed to send data from interactive forms within a PDF to a given destination. Therefore, it uses a special format for the file specification. It is a file specification with a URI path. The result is a file specification that acts like the URI action here. The keyword fields defines the data that should be transmitted. The connection is established via a HTTP host request. So to get a better understanding of how such attacks work, we're going to look at a real PDF. You can safely open a PDF in a plain text editor to inspect its contents. And at first glance, might look like it's indecipherable, but with the knowledge that we just gained or we gained earlier about the structure of a PDF, we could start to see how to decode this. The body or contents of a PDF file are listed as numbered objects. These objects begin with the object's index number, as I have here as 1, as well as a generation number, and the object keyword, as we can see on lines 3 and 19. They show the start of the definitions for the first two objects with 1 0 object and 2 0 object. The end of each object is signaled by a keyword, end object, as you can see on lines 18 and 19 for both object 1 and object 2. Object 2 immediately offers some clues here. If you look at object 2, we could see that it contains what's called a dictionary, in that these chevrons show that anything in between here is a dictionary. The dictionary has an entry for a JavaScript stream and a reference to object 1. This is a reference to object 1. Now this tells us that the garbage code in object 1 between the keywords stream and end stream is actually JavaScript, is a JavaScript stream. So all of this here is a JavaScript stream. Even better, object 1's dictionary is kind enough to tell us how to decode it. So here you see a filter. Line 6 shows a filter of value flate code, decode. Now you can write a decompression script that can show the plain code. Here's the decompressed code, and after it's been run through a sort of a beautifier, now we can read the JavaScript and determine it's malicious or not. In this case, the code appears to be contacting a domain called readnotify.com. Making callbacks to like phoning home without user consent shows at least a lack of concern for user privacy. For people working in journalism or in political sensitive areas, this could be a serious issue, as this kind of callback can reveal the user's IP address, operating system, and browser version to a remote server. Now, I think this is enough sort of traveling down our rabbit hole for this episode. We could go on and dig deeper into the malicious PDF, but the details would be too specific for only one attack. Each attack can use different methods. As I mentioned, there's the URL, there's the JavaScript, there's the embedded encrypted PDFs. But so if you get to this point, you're well on your way to deciphering the rest by yourself. Now, so far, we've broken down the high-level attack, how it happens, and looked at the basic technical structure of a PDF, as well as the PDF actions that can be used to initiate a malicious attack from a PDF. So we kind of know how we know how it works. We know what actions can be used and how they can be used. How do we stay safe? Here are some specific to-dos for PDF attacks or through phishing emails. You want to implement advanced email security. The first line of defense against malicious PDF is email security. You want to disable JavaScript on your PDF reader. If you're using Adobe Reader, then open Adobe Reader and go to Edit Preferences from the sidebar, select JavaScript, and uncheck Enable Acrobat JavaScript. You want to not allow PDF readers to execute non-PDF files using external applications. That would block the ability to open up a malicious Word document or QuickTime or Flash or whatever. You want to disable PDF readers from starting programs of Windows. You want to keep macros disabled. Malicious files might persuade you to enable, but you should not unless you're very, very, very sure and it's very necessary. Don't download or open a file attachment sent by some unknown email sender. It might sound great, but you don't know the person, so it might end up really messing you up. You want to ensure PDF reader programs and antiviruses software are up to date. You want to customize control. So with a bit of effort, users can customize how Windows handles NTLM authentication in case you click on a malicious link or a malicious link opens and passes your credentials through. With some effort, you can customize how that's handled. Now here are your general steps, which I've put into almost all of my videos. They help you not just in terms of PDF security, but in terms of overall corporate and security of your networks and your clients. You want to start off with educating your users so that they spot suspicious emails and activity and contact IT if they encounter anything suspicious. So, if any of the employees at my company see anything in terms of what looks like phishing email, like call me, it's important, send me your WhatsApp number, or some suspicious invoice PDF, they send it to me. Make time for regular offline backups and test the backups to ensure they can be restored from reliably. Should any employee unfortunately click on a PDF and unfortunately make your whole network succumb to a ransomware, if you have an offline backup, and what offline means is it is not connected to the network. It's essentially a system that has no access, there's no access to this system from your network. It's either turned off, the network cable is unplugged after the backup is done, it's stored somewhere remotely that can't be accessed. It is offline. You want to have a plan and review it regularly. Systems change, requirements change, and new vulnerabilities arise. So you want to make sure that based on the vulnerabilities that are out there, for example, your antivirus is up to the task. If you're using some kind of free antivirus that doesn't cover you completely or doesn't include, let's say, website protection, then you want to take a look at that and say, okay, it might be time to fork over the money for a more professional system. You want to review your infrastructure, your hardware and software regularly, because you may not know that somebody's inside your system doing recon. Most of these ransomwares take time for them to do their recon and find out everything you want to do before they actually do the ransomware. So you reviewing your infrastructure, your hardware, your software regularly can help you locate them before they have time to really learn about your system and perform the attack. Update systems regularly. Patches can fix vulnerabilities that somebody could be trying to exploit on a regular basis. You want to restrict write permissions, especially on file servers. Should you succumb to a ransomware attack through something like a PDF, malicious PDF, having the correct file permissions on the file servers or write permissions on file servers can restrict the ability for those file servers or your backup systems from also being encrypted and infected. Use advanced endpoint protection. Goes without saying. It's one of the specific to-dos for this particular episode and this particular problem of malicious PDFs. You want an endpoint protection that can identify new malware variants and detect malicious traffic. You want to use email and web protection. Again, specific to this, to block access to malicious websites and scan all downloads. You want to use at least a 2 firewall-based system. That allows you to protect against systems that may infect one and try to sort of call the command control server at home. You want to restrict outgoing connections where possible, part of the firewall plan. You want to disconnect from networks immediately if you suspect an infection. If one laptop gets infected and you rip it out of the wall, then it protects the other systems on your network from also being infected. You want to also get insurance wherever applicable. Hopefully you don't need it, but to have it and then be forced to try to call for over $15 million in Bitcoin without some kind of insurance is an extremely sad case. With that, thanks for your attention, and don't forget to share this video to anybody and everybody who you feel can really benefit from this information and knowing and educating them. I appreciate you taking the time to watch this video, and I look forward to seeing you on the next episode. Take care.